Hi, good evening, all. This is Vishal Singhal from CellStrat. We have today Mr. Gurumoorthy Loganathan. He will be taking us through recommender systems. He's AI researcher with CellStrat AI Lab and researching on NLP technologies. So, Gurumoorthy, I'm making you presenter, and you can start showing your screen
Okay,
now.
that's awesome. Thank you very much.
Go ahead.
Okay, we're able to see my screen.
Yes, you can go ahead. For the audience, I would say this webinar is being recorded. If somehow you drop out in between, you'll be able to see this webinar in a few days over CellStat YouTube channel. I'll be sharing the link in a few minutes over chat, as well as if you have any questions, you can keep asking them as and when they come to your mind. Unless they are slide critical, we will be answering all of them towards the end of the webinar. So go ahead, Guru.
Okay, hi. Hi, good evening, everyone. I'm Gurumurthy here. Have mobile number is given and email ID. This is my email ID. Uh, so I'm just associated with CellStrat. I've got more than 20 years experience in IT and associated with CellStrat. And then anyway, and before I start my session, let me in today's modern world, one second, please. In today's modern world, people have too many options. Like whether you want to watch movies, whether you want to order books or product, everything is available on the fingertip. And I have you ever thought how was our system or laptop able to suggest what exactly we need at the right item? It's not any magic here. You know what is the question answer behind this? The answer is the solution. You know, solution is the recommender system in which the whole session. This is what we are going to discuss about it, and we are able to achieve this recommender system through your algorithm. And example is your Netflix and Amazon. It's all done using the recommender system. Next, this is our agenda. What is the recommender system? Types of recommender system, how recommender system works, and just recommendation engine, and determining techniques used in recommendation engines and practical development. Let's start with it. And like we have types of recommender system. We have many flavors of recommenders. Right? We have recommend things. But I think this is something very normal. Like when you log into any Amazon, the first thing you get is like you just say what are the items that you prefer. Maybe you could have bought something, your this thing, any items or books, or you watch any movies, and the thing is, it recommends you the all. It comes with the list. I think that is something very familiar or common, of course. This is one of the recommend things. And the next is recommending content. Recommending if you have gone through any of the articles. So next time when you go through when you open any of the content, it will also the system recommends to go through this and content also. This is recommending content. Like when you're like music, suppose you say you listen to air music and you're very fond of music, and some for example, you say AR Rahman releases any album. Next time, the recommender system, your system, alert comes with the alert saying that you can watch this new one as new album as. I think this is very common. So this is the different flavors that we have in the recommender. Now we move on to what is the recommender system. So recommender system is the this thing sub of information filtering system that seeks to predict the rating or preference the user would give it to an item. I think this is something, this is given in Wikipedia, and they are primarily used in commercial applications. To make it very simpler, I say like it predicts user preferences for a product or a service based on a user profile and history. There's the some of so this is recommended system definition. We have this is a very common that will be using of course this prediction. You can estimate how much rate the user would rate or like an item, relevancy, ordering to what most relevant to the user, then recommendation, top and most relevant items, personalization of the taste. I think this is very common, and I think you don't need many explanations. Okay, then recommender system. Let me talk about the data flow here. Suppose I say send the request for the top item list. Okay, first what happens is it retrieves the item from the catalog database that are more similar to the current user's taste. Next step is prediction is calculated using the user preferences retrieved from the user database. Then based on the calculated prediction, we get the significant items or output with the rating. So let me just give you an example. Suppose you want to predict something top movie list. First, what happens is it picks the top. The system will pick up the top recommended movies okay, from the catalog database to the user as similar to the current user base. Suppose it say, and then once it retrieves the movie list, then it has to calculate the prediction. Suppose it retrieves six movies from the list, and then it has to calculate prediction. Then prediction means comes with a rating. So then once it comes to the prediction, then it comes to the prediction. So out of the prediction, it takes 5 to 3 ratings only, and whatever that is less than that, it removes that. Okay. Then once it comes to the prediction, then it is followed by filtering. Then what is filtering here? Suppose I say out of 6, it has only selected 5. And this 5, the user does not like some science fiction or something, any other movie that is not common to him. It removes that, it filters and gives only the recommended movies that is similar. It gives the top recommended. That is how your data flow works in your recommender system. Then what are the different types of recommender system? We have collaborative filtering, content-based, hybrid, context-aware recommender system, and the model-based recommender system. We will see all this one by one. So collaborative filtering. So it builds the model from user past behavior, analyzes similar decisions made by other users. Suppose if you look at the picture here, so we have 2 users who have similar items. Okay, and the one user, because they have similar items, we use pizza and pizza, other something like sandwich or pizza, both like that. And then this, suppose the user one who drinks pizza, what happens in this case is system recommends the other user to taste Coke also. This is your collaborative filtering. A collaborative filtering system works by collecting user feedback in the form of ratings for items in a given domain and look for similarities in rating behavior among several users in determining how to recommend an item. Okay, so these are the assumptions, like people with similar preferences in the past have similar preferences. People preferences will remain stable and consistent in the future. So next is we have different types of collaborating filter. In this we have user-based collaborative filtering and the item-based collaborative filtering. See, first is when we talk about user-based, it's something similar users based on similar user preferences, and recommend new items to an active user based on the rating given by similar users on the items not rated by the active user. This is something very similar that you can suppose you have a user A and B, and user A and B have similar items on the book. Suppose this user item A has bought some book. So system will recommend the user A to buy this book also. So this is nothing but the user-based collaboration. This works on the user-based collaboration. That is how we see on the screen. Okay, this is something very common across your Amazon or Net. So the next one is your item-based collaborative filtering. Calculates the item similarity based on the item preferences, and it is between item to item. And suppose you say, for example, you are suppose you like apple, the system will also recommend to buy to eat taste your pineapple also. It is between item to item. That is one of the collaborative systems we have to pick. And another word we can call this as a collaborative filtering is also another term is also called as user experience. So when we this thing following or taken into consideration for collaborative, calculate the similarity between users, calculate the similarity between items. Based on this, recommendations are generated. Mainly, the main advantage of using this deal with new items and new users and data whose data is not. So one of the major problem is the cold start. Cold start is that a new user is introduced into the data set and the system does not know anything differences of that. Okay, and anyway, this is just anyway we are going to see this in this example. I'll show this in the thing. So next is your content based recommend item based on the comparison between the content or future of the items and the user profile. When you look at this picture here, so it is basically, it doesn't work on any user history profile. It doesn't work on the rating here. It works on the user profile and the content. So if you look at this one, so we have three pictures. You have mystery, science fiction, and the romance, and you have the user profile here. One based on the filtering, it only shows these two pictures. Okay. Basically, based on the user preferences, it shows your content. Content is basically based on the content items and the user. So I think by looking at this, it's very easy to understand. Since it does not like the science fiction, it does not show the science fiction. It like only the mystery and the romantic. Based on the it shows the other similar items based on the Titanic and the other movies. Sorry. So when you say knowledge-based recommender system, it is basically like it does not depend on any ratings or anything. Right? It is based on the user's past actions or ratings. Suppose when you go and buy a car or when you go and buy a house, you don't need all any rating. You get the recommendation from the ratings of from the peers. Okay. So knowledge-based systems are unique in that way they allow the users to explicitly specify what they want. Suppose when you go and buy a car, when you go and buy a house, so you specify something. I want this kind of this manufacturer or this model. Or the same way, if you want to go and buy a house, you come with your specification, your total square feet, how much of your BHK, and so on and so forth. So this is one of the knowledge-based recommenders. So hybrid is nothing but the combination of both content based on the collaboration that we call it as a hybrid. This approach suggests a good mix of recommendation to personalized level and better neighborhood. And then context-aware recommender system. This is a personalized recommender that is targeted to the end user. And here context represents the present state of the user. So maybe you can consider location, time, mood that defines the context of the user and suggest personalized action. Suppose, but if it is a winter, Suppose, for example, you say if you look at this figure, I think it's very can understand it very easily. Suppose if it is a winter, the system will recommend you to buy a jerkin or winter clothing, or if it's something very winter, very cold, it recommend us engines that just coffee in cold weather. Okay, this is the example of the context aware. And then if we look into that, the recommendation is built on 3-1 user item on the content. Whereas when it comes to content and the collaborative, recommendation is based on user and item. You will understand when we move to the next slide and it comes to the model. So model based. So this is the model based. See, whatever the one we discussed, your collaborative, it is called the memory based. Memory based in the sense, whatever the data that goes into the memory, and if the data set is very large, it takes very long time to predict it. So in order to overcome this, we have used this memory based, we have used this model based recommendation system. And model based recommendation involves building a model based on the data set of data. And model based collaborative filtering models are developed using machine learning algorithms to predict the user ratings of unrated items. Okay, and we will see more this in this coming example. And maybe if you use this model-based approach, it benefits benefits of both speed and the scalability when compared to your collaborative filtering. So,
Guru, there is a question.
pardon?
There is a question.
Tell me.
So, what is the difference between item-based and content-based filtering?
See, item based and the content based here. When we talk about content here, it is between the user profile and the content. Okay, it is between the user profile and the content. Okay, it doesn't talk about any history here. Okay, whereas in the user group, it talks about the history. Okay, so I told you in that one, the one content base. So you have a user profile and then you have a content, your mystery, your sci-fi, and your other romance. So based on the user profile, out of 3, it only gives the 2 movies here. Okay, because based on the preference of the user profile available, it filters and gives the out. That is the content base. Whereas user based, it depends upon between 2 users. It is between 2 users, that is basically based. It works on the collaborative filter. Is this fine? I can continue?
Yeah, go ahead.
Okay. So some of the techniques include here is k-nearest neighbor, clustering, matrix factorization, and the deep study. Anyway, this is for your reference. Anyway, this I'll go through with, I'll show you with more examples so that you can understand. So how your recommendation engine is nothing but a branch of information retrieval, and it's a powerful tool which analyzes huge volumes of data, especially your product information and the user information, and then provide relevant suggestions. All this is based on your data mining. Okay, that will see in the next what are the different approaches in the data mining. So recommendation engines works through the following. So one is called the data. 3 steps here. One is data collection, data storage, and filtering the data. Data collection, you have 2 types here. One is called the explicit data type and the implicit data. So explicit example is your movie rating. And implicit is your search history, click, and the order history is all the example of an implicit. And you can storage of data can be any standard SQL or NoSQL or any kind of object storage. And then you can filter the data based on the relevant information to make the final recommendation. So when we talk about recommendation engines here, it's only your objective function is between the user item, between the user and the item. And it measures and gives the usefulness of item I to user u given by this function u into I. User into item gives your recommended technical term. call this R is the recommender. It's a function of user and the item and gives the recommended item. So let us go through some, so like so Amazon, Netflix, and Twitter uses this recommendation. So it's just a fact here. So how many a number of users, like we have 89 million users, and in Netflix we have 36.6 million streaming subscribers and 8 million DVD subscribers, and Twitter we have. So by providing recommendation based on predictive analytics, these companies are giving their customers the ability to take the brand experience into their hands and make informed decisions. So this level of personalization support gives customer retention and reinforce brand loyalty. So some facts is two-thirds of movies watched by recommended movies and 30% click-through rate on Google News or recommended website or so on. So what are the different data mining? So data mining is nothing but it helps to extract patterns, group users, and calculate similarities. And it also helps to handle sparse input data. Sparse input data in the sense you have user and the item, in which you don't have the rating for some of the columns. So even it is able to handle the sparse data and evaluate recommendation models. Okay, so these are the one technique that you're going to, that is in this your data mining techniques. These are the different techniques that is used in the recommendation, like mathematical matrix factorization and the singular value decomposition. In neighborhood, we have Euclidean distance, cosine similarity, and pairs. These are all different techniques. And machine learning, we can also use your linear regression classification, clustering, and the vector space term frequency and the term frequency insert. And once you have built the recommended, you can also evaluate your recommended system based on root mean square and the precision. So in this, I'll show the I'll show the practical demo based on your matrix factorization and the singular value. Okay. Before that, I'll just go through some of the.
Guru, another question here.
Okay.
Does recommendation system works with live streaming data or just recommend a new connection alone?
No, it has a matrix, it has a database. Based on the database, it works on that. What my this thing? Repeat, is this fine?
So my counter question to that, you are saying it works on the database, but suppose a new customer is coming in and based on previous data recommendations, will it not work?
Yeah, sure, it works. Yeah, that is what collaborative filtering. We have a cold start. Okay, this is called the cold start problem. We say, okay, if the system doesn't have any preferences about the user, first thing is it asks something about what is the movie you like. All this, it gets all the preferences from the user. Okay, and then from next time onwards, it starts working. First time, it doesn't have any idea. It gets the input from the user. So this is what we call this is a code start problem. So in order to overcome this problem, first time it gets the data from the user first time when they initially log in. What is their interest? All this it gets all the input. Based on that, it starts working. Did you get my point?
Yeah. Okay.
Can I continue?
Please go ahead.
Wait, I got okay. I'm not moving here. So equilibrium distance, it's very like this is the path distance between 2 points of vectors and vector space. This is the equation we given it. Suppose let me show these three users with ratings for 5 movies each day, And we have first thing is we give equidistance U1 and E2, it gives 7.4. Then another Euclidean we have U1 and U3. So user based on this, we can very well say that user 1 and 3 have much smaller equivalent score. So we can very well say U1 and U2 have extremely different tastes, whereas tastes of user 1 and 3 are largely small. So cosine similarity, like suppose mostly it is used similarity between items. So in this case, the cosine similarity is being used here. Suppose we have, if you want to find the similarity between items between two users, based on this formula, we can get this. If the angle is very less, we can say the similarity is more. If it's more, then we can say they have similarity. We have more dissimilarity in this. So we can use this cosine similarity. Then we have Pearson correlation. It is between your -1 and 1, indicates total negative, whereas 1 indicates total positive correlation. 0 indicates that the two entities are in no way correlation. That is, we have positive correlation and the negative correlation, and 0 indicates that is no way correlation. This is given by the following example. We have Alice and Bob have the highest possible similarity score, whereas Alice and Eve have the lowest possibility score. From this, so clustering also is one of the most popular techniques used in collaborative filtering. As you know, it's nothing but unsupervised learning. Groups data points into different classes. That data points belonging to a particular class are more similar to each other than the data points belonging to the class. So if the user A and has opinion of a product as user B, then A is also more likely to have the same opinion as B on another product than that of a randomly. So counter vectorizer. So we can also use counter vectorizers in your recommender engine. So this is one simplest type of vectorizer. Just I'll show you an example. The sun is the star A, B, C, and we can make this as we can eliminate the stop word, and we have vocabulary like little lamp, and we can make this as a vocabulary as in this one, and then using the counter vector operator A, B, C will be represented in this. So 0, 0, 0. In this A, the sun is the star. In this, if you look into this A, the sun is the star. The sun is repeated once, and star is repeated. And if you look at the B example here, I think red is repeated twice, so it is given by 2, and rest is all 1. Same thing. See, Mary had a little lamb. All this repeated once and showing the 1. The rest is all 3. So next is this TF IDF vector is upgraded as term frequency. It assigns weight to each word, and this is given by the formula. And I don't want to go much deep into that. The reason for using TF IDF is assign weights to each word in a document. And advantages, it speeds up the calculation of the cosine similarity score between a pair of documents. It is means pair of documents. Where in this case, TF IDF is used, TF count vector is used between pair of words, in this between a pair of documents. Next, root mean square. You can also, in order to predict, you can also evaluate your recommender system, you can use your root mean square. You know, it's very like all of you are familiar. This is something your difference between your actual and the predicted value. You've been generally used in a linear algebra. And then precision and recall. Okay. And next, we come into your singular value decomposition. So what is the singular value? Singular value decomposition is nothing but same as SVG, and it's the matrix factorization, and we can decompose the matrix of any size into a product of the 3 matrices. So we have A is a matrix, okay, and then it is given by U, E, V, and transpose, and U and V are called your left singular vector and your right singular vector, and they are called orthogonal matrices, and D is the diagonal matrices, and this is how the dimension of factorization decomposition, I don't want to go much deep into it. This is how it just decomposes matrix into three, U, P. Okay. And before that, what I want to say, like whatever that now I am going to look into here example based on the users and your items and okay. So U represents your user item and B transport represents the I. Okay. And D is the nothing but your singular value based on the state. This is how. So what is that I am going to? This is I am going to explain. Okay, one matrix based on the user and the item and the rating in the form of a stored in the form of a matrix that I am going to show you the with an example. So next, what is the overview of SBD here? This is this is a very mathematical. This SBD is a mathematical technique, and it has been widely used across your industries like data reduction. So when we say talk about data reduction tools, you're like suppose you have high dimensional data, maybe you have megapixel images, you have high megapixels, or you have EDR with very high resolution, and you have other very big data, and SBD will help us reduce this data into key features that are necessary for analyzing, understanding, and describing this data. SBD is one of the first step in most dimensional reduction. Okay, and this is where it is a data reduction tool, and is also used in recommender system and used anywhere in your Facebook, Google, and Microsoft. Like it is used in the Google page rank algorithm using SVD. Basis for and Facebook also uses facial recognition algorithm to tell which person who from an image. Okay, so SVD. So these are all this is used anywhere in this one. And it is risk modeling in equity investment, identifying generic brain imaging that makes the participant situation. And FPD is simple and interpretable, meaning we can use we can use it really at any time. You have a data matrix and compute FPD, and we get interpretable, understandable futures that you can build. Okay, we'll just go for it. Do you have any questions?
No questions as of now. You can go ahead. We will wait for questions from audience.
Let's start with it. So what I will do here is I will start understand. I just show the one how to build a simple recommender. Okay. So now I use this movie lens data set here. In this I have a movie metadata. Okay. So when I run this, these are all the columns. You have language, original title, overview, release date, revenue, runtime, spoken languages, status, tagline, okay, both average and the post. And the example of building a simple recommender system based on the rating. Okay, what is the next step I'm doing here is I'm calculating the number of scores garnered by the 80th percentile movie. Meaning in the sense, whenever you take any rating, the rating should be more than the 50%. Okay. It cannot be less than that. So I'm using this formula here. We have a column called O count in this movie metadata and quantile 80. I'm giving it return 50. Okay. Then I'm next thing is I'm just consider movies longer than 45 minutes and shorter than 300 minutes, and then I have this. I'm taking this is the criteria I'm taking, and then I'm calculating the fee. So this is really required of calculating why I need to calculate. If I have a rating directly, I can use it, but that won't be feasible. For 1,000, suppose if we have 1,000 users, if they have predicted that as a of move that they have seen is comes around the rating as 5. Suppose if you have 100 movies, suppose if you have 100 users, they have seen some documented movies in which they have come the prediction as 5 or something. So we cannot go for the rating alone. So in order to overcome this problem, we calculate the mean by using the column the vote average dot mean, and we get the average, and we calculate mean or average of that vote average. Then we have a function to compute this weighted rating for each movie. Like we have a function, like suppose we vote count by vote average this function. Based on this function, we calculate the weighted rating for each movie, and then we run this one, and then arranges your movie in the descending order of the. So if we look into it, we just have a following column title from vote
Guru,
average.
one question.
Yeah.
Any reason for selecting 80% quantile?
Yeah, that is the one. So 80%, that is the one model that we have to use it here. That is for the formula we have to use it. Then only we get this. See that this many users. This is nothing but to find the rating. When we say the rating, it should not be less than 50. So we need to check whether the rating given by the user of the each movie crosses that 50. So in order to do this, we use this quantile as 80. This is standard that we use it of 80%.
Okay.
So once we run that, we get the short movies in descending order of the score. So if you look at this one source like vote average, if we say, you can see the rate. Based on the vote average, it comes with the movies with to sorted the movies in the top of the shown down based on the rating. So this you can just make a simple recommender by using this kind of a data set. Another thing I have is called the knowledge one. Knowledge database set. So this is what I'm doing here is like here. I just show you that I have just built a function. I have just built one function in which I accept that laundry input or duration, then longest duration, what is the earliest year, and the input latest year. So based on this condition, okay, I just run this, and then this one. What is the what is I get the input as animation. I give the input. What is that I entry animation 100, 200, and then based on this I get. This is one of the example of the knowledge based duration, and the one data set which I am using is this same database which I am using that in the research one I am using movies metadata, and the column which I am using is your title, genre, runtime, vote average. So based on this, I am building a logic here and getting the input, and then based on the input, I get the output. This is example of a knowledge.
Another question, Guru.
Yeah.
For instance, I rate 4 star for a movie of a certain genre. Next movie I watch of same genre, I rate 1. What happens next? Does recommendation work based on some other parameters as well? Extension to that is, and recommend same genre or a different genre would be recommended.
Can you repeat the question, please?
Question is, for example, for I rate a movie 4 star for a certain type, and next movie I watch of the same type I rate 1. What
Okay.
happens next? Will the recommendation work based on some other parameters as well? And extension to that is, will the same type of movie will be recommended, or a different type will be recommended?
See, whatever it is, recommended system based, it takes only the top rated one. Like it will not take only the one rating at all. Okay, it will take between 5 and 3. It will take between the 5 and 3, and then recommend and give it. The top ratings only it gives. This is how
Okay.
it works.
And what about the recommendation next time? Will it be same type or a different type?
What is it now? What pardon? What is the next
So,
question here?
so first question is clear that it will take between 3 to 5 rating. The second
Yeah,
question is, will it recommend the same type of movie or will it recommend a different type?
it is based on the user profile only. If you it is based on the user profile. If you like if you are in if that whatever the genre you select, okay, whatever the genre you select, and based on the rating, okay, if you like that movie, it will show that it will come in the recommended. It will come as in the recommended.
Okay.
Is this answer? Huh?
Yeah,
Answer?
likely. Yeah. Thanks.
Okay. I'll just move on to the one. Next one is I will I will next example is I'm going to show an example using your single value decomposition. So what happens here is I take a movies one movies data set, and this I have rows, and this is the rows and columns you have movie ID, title, and genres. And then next I take the rating. Next I take the rating this database, and then I in which you have three columns like user ID, movie ID, and the rating. Okay. So now I have these two matrices. Based on this two matrices, based on the two data frame, based on the two data sets, I build a data frame. Okay. This is I build the data frame in which I have a user ID as root and movie ID as column. Okay, and then the middle one base, and then whatever the I and j element represents your rating. Okay, and now I want to explain one thing here. And now what I'm doing is once I build the matrix user ID as a row and the column, then column movie ID as a column. If we will not, the user would not have rated the rating for all the movies. Okay, so we cannot list that as a blank. So what I do is, whichever the one which has got blank value, I fill this as row. So once you run this is the one you get. Whatever the one which has got the user has not rated, it comes with the user. Now, once your matrix is ready, once this matrix is ready, then you have to normalize by each user name, and then I'm converting your matrix from a data frame to a numpy array. So I'm just using np.me, user me, and then make user, and then I demean the data using your numpy. Now we have your all set. Now you have your data set. So you have your matrix with the uh, row as a user ID and the column is a movie ID, and with all your whatever the columns is, and that I throw on the base column with the rate. So we have your matrix. Now with my ratings matrix formally form, I'm normalizing, I'm ready to do the singular value decomposition. So I use this SciPy for linear, like this one, import experience, and then once I run this experience, I get this U, sigma, and U, sigma, and the VP. So U represents your user one, and V transpose represents your item one, and sigma is your singular item. So I am just converting the singular value into your diagonal. So once I get this, okay, once I get this, I just run the dot product. I'm just multiplying of two matrices and U and sigma along with the user and get your user predictor rating. Now previously you had your one with 0. Now after decomposition of matrix and then decomposition U, sigma and VC and then running the multiplying your matrices with U and sigma into VC, I am getting all the user rated. And now I've written a function. I call your prediction database and your movie, your rating to return the top 10 units for the user. Once I run that, I get this user who was already rated and then recommended item. So whatever the user has rated, the 76 movies is also I just count. So in this, I also see how much the user who has rated that movie. It shows that user who has already rated 76 movies, and then the recommender recommends your highest predictor rating movie that already not rated. Using that prediction, you see that what are all the movies that we can see from rated movies. That's the So what I am doing actually in a summary, what I will do is, so I am taking two data sets. One is your movie, other one is your okay, and then I make this as a data frame by using these two columns. And once I make this as a data frame, we find that some of the columns in your some of the columns by some of the columns in the user has not given the rating. So in order to so I make the some of the columns as 0 not rated. So now after this I take I take the mean of the data because it will have the ratings between 1 to 5 and making that normalizing the matrix here and then converting your data frame by using NumPy and the StatPy. So for that what I am doing is I am calling this function. Once the matrix is ready, now I am calling your XPDS function. So by calling XPDS function, I am decompose your matrix into three matrices called U, sigma, and your V. Okay. And now whatever your sigma returns is going to be your singular value. I'm converting that into diagonal value. Then once I get this, I have to whatever the matrix I have, I'm just multiplying it back and get your predicted rating. So I am using this dot product of this NumPy, in which it is multiplication of two matrices between U and sigma, and then gives us a package with all this one is being stored in here, all user ratings. Once this is done, and then I return the movie with the highest predicted rating that specific user has not already rated, which I am calling this recommended movie, in which I pass this argument predict here and choose the user and movie here rating all this, and then we are just recommending a system to predict 10 crores, in which once we have already have two already rated, in which I run this already rated by the I show this one already rated and these are the ones which user was already rated, and that message we get is the scientific movie, and then the prediction the movie has not rated. So this is how your is this clear? So mainly why we use SPD here over collaborating filter here is mainly like it is able to handle sparse data. It is able to handle sparse data in the sense like if you don't have a data, it will if you don't have a data, SPD uses the sparse matrix and fill that with the rating, and then give your, this is one of the main advantages. You can handle sparse matrix, and when you run it, it is very fast, and you can retrieve the items in a very faster way. That is the main advantage of using. And the other thing is like even this, even you can also use, even you can use your personal component analysis, but we cannot. Another this thing is like this same thing can be achieved by principal component analysis. The difference between your principal component and analysis and the HPD is for the principal component, you should have all the columns, you should have values. Then only you can use principal component analysis. But even if you don't have values for some of the columns, then you can use HPD. Using sparse matrix, you can run it and get the recommended items from the. This is how it works. Is it clear? Any questions? Hello?
Any questions, audience? Guru, would you be able to share your notebook for future reference?
No. What your examples is asking, or the examples, sir?
The Jupyter notebook that you have just shown with all the code and everything, would you be able to share that? Do you have a link of that?
Generally, I don't show it. Okay. Generally.
Okay, that's fine. That's fine. So audience, you can have a look at it again on our CellStrat YouTube channel. I'll just give the link here.
Can get back to me, my email ID, or share my phone number. If you want any help, I can help you out. I mean,
Guru, probably you can show your screen again, the PPT on your contact details. So if anybody wants to contact you directly, they will be able to do that. And I'm sharing with all. I've shared with all the CellStrat YouTube link. You can watch this webinar again in a few days, probably in about by Monday or Tuesday. It should be up and running. So you will be able to see this as well as any others, previous ones and future ones as well that we'll be doing. So any other questions here? So people are saying it was nice presentation, Guru. So
fine.
thanks for all the explanation.
Fine. Okay.
So I don't see any other questions coming. So we have a careers webinar tomorrow and our AI Lab session in Bangalore and Gurgaon day after tomorrow. And a lot of webinars already lined up in February. And if all of you are in Bangalore, we have a AI conclave coming, which will be showcasing some of the cutting edge retail AI solutions. So look forward to see you there or in future webinars. So thank you, Guru, and thank you all for attending the
Thank you.
webinar. And look
Okay.
forward to more sessions by Guru in future. So good day to all. Thanks.
Okay. I'll just disconnect.